Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. The Carolina Bays are shallow elliptical depressions along the east coast of the United States. A widely accepted hypothesis proposes that the Carolina Bays were created by Aeolian and lacustrine mechanisms. Although this hypothesis has failed to explain how wind and water created the precise mathematical geometry of the bays, there is ample evidence that wind did play a role in sculpting the landscape. A conference paper presented by Christopher Moore and Mark Brooks in 2011 identified many long parabolic dunes and nested parabolic dunes in the upper and middle coastal plain uplands of North and South Carolina. The sound source for many of these dune deposits appears to be derived mainly from first-order streams, which are the smallest tributaries of rivers. The authors state that the dunes are Aeolian in origin and appear associated with dominant westerly winds. Moore and Brooks provide this example of a LiDAR image from Fort Bragg with evidence of large-scale Aeolian reworking and sand deposits along the major interfluvial divide between Lower Little River and Rockfish Creek. The image is labeled with parabolic and nested parabolic dunes, as well as surfaces deflated by wind erosion. Parabolic dunes, or chevron dunes, can be found along the coasts of many land masses. The chevron dunes are formed when a large wave, like a tsunami, scours shallow banks along the shore and carries sand inland. The characteristic parabolic dunes are deposited when the rushing water loaded with debris stops and then retreats back toward the sea. Earthquakes, volcanic eruptions, landslides, and cosmic impacts in the sea can create waves large enough to produce chevron dunes. An impact in a small body of water, like a stream or a lake, can also produce splashes that deposit material along the banks. In this experiment, a stone dropped in a bowl of water produces a wave that goes beyond the margins of the bowl as a splash. The Aeolian hypothesis has not been able to explain the mechanism by which the Carolina Bays achieve their mathematically precise elliptical geometry. Since ellipses are conic sections, the glacier ice impact hypothesis proposes that the Carolina Bays were made by secondary impacts of glacier ice ejected in ballistic trajectories by a meteorite impact on the Laurentide ice sheet. The impacts of the ejected ice boulders liquefied on consolidated ground, and the ice projectiles created inclined conical cavities that were remodeled into shallow elliptical bays by viscous relaxation. The saturation bombardment by pieces of glacier ice provided many opportunities for creating splash chevrons when the ice boulders hit streams and rivers. Big Bay is located 3 kilometers north of Pinewood, South Carolina, and 8 kilometers east of the Wateree River floodplain. This LiDAR image shows a band of deposits over Big Bay and chevron dunes in several places. The band of deposits has been described as an Aeolian sand sheet, but due to its proximity to the river, the sand sheet could be debris deposited by the wave of an impact on the Wateree River during the ice bombardment that formed the Carolina Bays. The terrain features can be explained if impacts by two ice boulders created Big Bay and its lower companion bay. Seconds later, another big boulder impacted the Wateree River. The splash from the impact dredged the sandy deposits along the river bank, and the sandy soil was carried by a wave 6 kilometers inland. The sand sheet was deposited on a portion of Big Bay and its companion bay. A few seconds later, a small ice boulder came down to create a small bay on top of the sand sheet. We will now take a look at other examples of splash chevrons. This is a LiDAR image of the Hughes Old River 14 kilometers north of Jesup, Georgia. The Hughes Old River is a minor tributary of the Altamaha River, but sometime in the past it was about 10 kilometers wide. The islands in the center of the river's floodplain show splash chevrons. How can such a small stream have such a wide riverbed? One possibility is that a large volume of water was released from the melting of the glacier ice boulders that formed the Carolina Bays. These splash chevrons are on the east bank of the Canoochee River near Pembroke, Georgia. The debris from an impact usually produces a symmetrical splash that should create splash chevrons on both sides of the river, but the material ejected by a splash during a strong windstorm will be blown in the direction of the wind. In this case, a westerly wind could have created these chevrons that point toward the east. Most of the Carolina Bays in this area have been destroyed by water erosion, and there are just a few impact dimples on high terrain. This is an image of splash chevrons 16 kilometers southwest of Bamberg, South Carolina. The chevrons extend for 6 kilometers from Georges Creek, and they provide an interesting geological puzzle because the source of such large chevron dunes is not evident. The creek is rather small, and we can only speculate that perhaps an impact on a lake or swamp at this location could have provided the sand. From the law of superposition, we can determine that the chevrons were in place after some Carolina bays had formed, and smaller ice boulders then fell to create small bays on top of the chevrons. These are some splash chevrons on the islands of the greater PD River in South Carolina. A closer look shows the tortuous path of the river with many oxbows in its current floodplain. An island in what was once a broader river has many chevron dunes. The LiDAR image shows that some Carolina bays were covered by the chevrons, and then other Carolina bays formed on top of the chevrons in a very dynamic terrain-altering scenario. Many features have been eroded by water since their emplacement. The chevron dunes 15 kilometers northeast of Sumter, South Carolina, are found for several kilometers in the east bank of a channel that is now dry. The whole area is pockmarked with Carolina bays. There must have been plenty of water in the channel at the time that the splash chevrons were formed. A satellite view of the same area shows a ribbon of green along the channel, and the rest of the landscape is a patchwork of farm fields with no evidence of Carolina bays. The dense vegetation along the channel may be an indication that the chevron dunes are not aeolian in nature, since the wind would not have been able to carry sand from terrain so heavily covered with vegetation, although it is possible that the vegetation is of more recent origin than the chevron dunes. In this image, we see that the width of the Lynches River is very small compared to its 2.5-kilometer floodplain. The splash chevrons are on the east bank of the river, as was the case for all the chevrons that we have examined. There are no chevrons on the west bank. The direction of the chevron dunes is well defined, and they can be used to determine the direction of the wind when the dunes formed. Kelly Bay in South Carolina clearly demonstrates the geological principle of superposition. This detailed image shows that Kelly Bay was created first, and then the chevron dunes were deposited on top of the bay. The dunes were created from splashes of impacts in the riverbed during the ballistic ice bombardment. A few minutes later, the upper chevron was hit by a small ice projectile with a higher trajectory that made a small bay on top of the chevron. The stream bed still retains the faint rim of an eroded bay. All the bays and the chevrons were created within a few minutes during a horrific hailstorm of glacier ice ejected by the extraterrestrial impact on the Laurentide ice sheet. It is worthwhile pointing out that the major axes of the Carolina bays are oriented from the northwest to the southeast and originate from Saginaw Bay, Michigan by the Great Lakes, whereas the direction of the chevron dunes is almost perpendicular to the orientation of the bays and was probably influenced by strong westerly winds that prevented the expected symmetrical emplacement of splash dunes on both banks of the river channel. This is another example of a splash chevron with a large sandy deposit. After the chevron formed, it was impacted by one or more ice projectiles. The chevron shows many pockmarks of small impacts and what appear to be several large overlapping impacts. The outline of a bay measuring 550 meters is still well defined. The image displays the roads and the state line boundary. The tip of this chevron dune is in North Carolina, while the major part of the dune is in South Carolina. I was intrigued by the name Gum Swamp Creek, so I used the street view of Google Maps to look at the bridge over the creek. Sure enough, it is a swampy area with standing water. Impacts by glacier ice projectiles with energies of 13 kilotons to 3 megatons of TNT on swampy ground would surely have ejected a large quantity of sandy soil that, carried by a strong westerly wind, would have created a splash chevron on the east side of the creek. Goldsboro, North Carolina, is situated by the Neuse River. This LiDAR image shows the splash chevrons along the bank of the river. Once again, the chevron dunes are on the east bank of the river and they are pockmarked by small Carolina bays. This image shows the location of the city, the roads, and an airstrip. The satellite image of the same area shows that urbanization uses all the land and the Neuse River has been constrained to a small channel. This image provides a broad perspective of the dune directions. We examined 8 examples showing that the wind direction had headings from 68 to 85 degrees. The southern latitudes in Georgia were associated with westerly wind, whereas the northern latitudes in South and North Carolina were associated with wind from the southwest. This map shows Saginaw Bay and the wind directions deduced from the orientation of the splash chevrons along the east coast. The extraterrestrial impact in Saginaw Bay during the Ice Age ejected pieces of ice in ballistic trajectories with speeds of 3 to 4 kilometers per second. Pieces of ice launched at 35 degrees reached a 500-kilometer range in 4.5 minutes with a maximum height of 87 kilometers. Ice pieces launched at 45 degrees had a flight time of 5.3 minutes with a height of 125 kilometers. The east coast came within range of the ice boulders from 6 to 7 minutes after the extraterrestrial impact. Pieces of ice launched at 35 degrees reached a 1,000-kilometer range in 6.3 minutes with a maximum height of 175 kilometers. Ice pieces launched at 45 degrees had a flight time of 7.5 minutes with a height of 250 kilometers. North and South Carolina were hit by the ice boulders between 7 to 9 minutes after the extraterrestrial impact in Saginaw Bay. Pieces of ice launched at 35 degrees reached a 1,500-kilometer range in 7.7 minutes with a maximum height of 263 kilometers. Ice pieces launched at 45 degrees had a flight time of 9.2 minutes with a height of 375 kilometers. As the pieces of ice made landfall, strong westerly and southwesterly winds carried the splashes to form chevron dunes. Where was the jet stream during the ice bombardment? Jet streams are fast-moving ribbons of air high in the atmosphere, and they shift positions based on the seasonal inclination of the Earth toward the Sun. A jet stream forms directly over the center of the strongest area of horizontal temperature difference. The polar jet stream has winds of 125 km per hour, which is about 78 miles per hour. These hurricane-force winds are usually 10 to 14 kilometers above the surface. The direction of the wind that formed the splash chevrons is consistent with the path of the polar front jet stream during the winter, shown here in blue. The polar jet stream blows eastward in Georgia and in the northeast direction in South Carolina and North Carolina. Although the jet stream is usually high in the atmosphere, it is possible that the massive ejecta curtain of falling ice projectiles shifted the strong winds toward the surface where they affected the emplacement of the chevron dunes. We need to study the geology of the Carolina Bays to find the wind speeds necessary to produce the chevron dunes that are found along the east banks of many streams and bodies of water. Geologists will need to examine these chevron dunes to see if they consist only of small grains of wind-blown particles or if the chevrons contain coarse material that could not have been carried by the wind and thus provide evidence that the dunes were created by splashes made by violent impacts on wet and swampy ground. Confirming the source of the chevrons will increase our understanding of what happened in North America 12,900 years ago. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.